Studies. I am Bala. Today I will explain about mole concept from chemistry. So before going to mole concept, some basic terms we have to know. So first one, atom. First one, atom. So the term atom was introduced by John Dalton. John Dalton. The term atom was introduced by John Dalton, and he said that atom is a indivisible particle. Atom is an indivisible particle that takes place in a chemical reaction. The John Dalton said that atom is a indivisible particle that it takes place in a chemical reaction. It is an indivisible particle. Atom looks like, see here, this is an atom. This is an indivisible particle that takes place in a chemical reaction. Here you will get doubt. Sir, what is chemical reaction? What is chemical reaction? Chemical reaction means the rearrangement of atoms takes place in a chemical change. What is chemical reaction? Rearrangement of atoms that takes place in a chemical change. So if you see here, this is one of the atom and this is one of the atom. It gives C as a product. Here very important point, A and B are reactants. A and B are reactants and C is a product. C is a product. Okay? So remember this point. And here, when we combine these two, A and B, we can get a product C. Okay? So that is known as chemical reaction. Okay? So atom is an indivisible particle that takes place in a chemical reaction. Okay? So this is the definition. This was given by John Dalton. He introduced the term atom, and an Indian philosopher, Maharshi Kanad was an Indian philosopher. He said that Anu is a molecule. Anu is a molecule, and Parmanu is a atom. Okay? Anu means molecule and Parmanu means atom. Okay? He said these two terms. So this is the introduction of atom. Next one, molecule. Here, molecule is invented by Avogadro. Molecule is invented by Avogadro. So he said that molecule means combination of two or more atoms. Molecule is invented by Avogadro, and he said that combination of two or more atoms is known as molecule. For example, here I am taking oxygen. Oxygen is symbol O. This is an atom. So here we can find the molecule of oxygen O2 by combining two atoms. Why we have to combine means, for getting stability we have to combine two oxygen atoms, so that forms O2. Okay. So this is the molecule and it is invented by Avogadro. Okay. Next one, and we learned that atom, molecule, these two are very important terms. And in mole concept, first we have to know about laws of chemical combinations. Chemical combinations. Laws of chemical combinations. So if you see here, in this there are three laws. In this there are three laws. Okay. So in first one, law of conservation of mass, and second one, law of constant proportions, and third one, law of multiple proportions. Okay, so these are the three laws in law of chemical combination. Actually there are 5 laws. Remaining 2 laws are gaseous state, so we cannot discuss about those 2 laws. First we have to know about these 3 laws. Okay. And first one, law of conservation of mass. Okay. So this law was invented by Anthony Lavoisier. He is father of chemistry. He is a father of chemistry. Father of chemistry. And this law states that mass is neither be created nor destroyed, but it converts from one form to another form. Okay, so this law states that mass is neither be created nor destroyed, but it converts from one form to another form. Which means, here in this law, the best example of this law is chemical reactions. CaCO3. Okay, I am taking CaCO3, and if I heat this CaCO3, the products are calcium oxide and carbon dioxide. Okay, First note on this, I will explain again. In law of conservation of mass, there is a best examples. There are so many examples. In that, best examples are chemical reactions. So I am taking here CaCO3. If I hit CaCO3, calcium oxide and carbon dioxide will be formed. Okay? So here CaCO3 is 100 grams. How? Ca is 40 grams and calcium is 12 grams. O3 means oxygen 3 are there. So 16 into 3, 48. So if we add these 3, we will get 100 grams. Okay? And this is compound of 100 grams and this compound of 56 grams. 56 grams. And the CO2 mass is 44 grams. Okay? So if you see here, this is a reactant. When you heat this reactant, 2 products are formed. So here the reactant is only 1. So here reactant mass is 100 grams. So here there are 2 products. If we add these 2 products, the mass of these 2 products is 56 plus 44, 100 grams. So the law of conservation of mass is approved. Okay? When the reactant's mass and the product mass are same, then that chemical reaction is balanced and the law of conservation of mass is proved. Okay? Here note point is, here these 2 are reactants. I am adding these 2 reactants and the products are C plus D. Okay? So these are reactants. These are reactants and these are products. Okay? And here another important point. Mass of reactants is equals to mass of products. Okay? So this is one of the important point. Mass of reactants is equals to mass of products. Okay? Then we have to consider the law of conservation of mass is proved. Okay? Another example. In a chemical reaction, A mass is here they gave one of the example. In a chemical reaction, reactant A mass is 12 grams and reactant B mass is 14 grams. Here we have to consider a chemical reaction. A plus B gives C plus D. Okay? So the A mass is 12 grams, B mass is 14 grams. Okay? So if we add these two, 26 grams will be the total mass here the 26 grams is the total sum of these two reactants. If we subtract 15 grams from this, we can get answer. See, 26 minus 15, 9. So here the D mass is 9 grams. Sorry, 11 grams. Okay, so the D mass is 11 grams. If we add these two, the total mass is 26 grams. So both are equal. So we can consider law of conservation of mass is proved. Okay. And in law of conservation of mass, we have to consider the mass of solids, liquids and gases also. We have to consider the mass of solids, liquids, gases. We have to consider the mass of solids, liquids, gases because those are also a part of chemical reactions. Okay. And here another important point. First note down this. And here in law of conservation of mass, the best examples are physical changes, chemical reactions and fermentation. Chemical changes, physical changes, fermentation, and so on. There are so many examples of law of conservation of mass. So these are some of the examples. Okay, and the law of conservation of mass is completed. And then the second law of constant proportions. Law of constant proportions, and this law was introduced by Joseph Proust. This law was invented by Joseph Proust. In this law states that a chemical reaction in a chemical reaction the compound is always forms same elements by fixed mass of ratios. This law states that in a chemical reaction, the compound is always forms same elements by fixed mass of ratios. For example, first note down this. For example, CO2. Here carbon weight is 12 grams, oxygen weight is 32 grams. Okay, carbon weight is 12 grams. oxygen weight is 32 grams. So if you see here, the ratio of these two is 3:8. The ratio of these two elements is 3:8. So here 3:8 is nothing but the fixed ratio of these two elements in any compound. Okay? And here, if I take 24 grams and 64 grams, 24 grams, 64 grams, same ratio. See, 3:8. So we can say that these two elements are always forms fixed whole number ratio. Okay? So this is one of the example of law of constant proportions. So this is law of constant proportions. So what is law of constant proportions? In a chemical reaction, the compound is always forms a fixed number of elements. In a compound, a fixed number of elements. See, CO2. In a compound, same elements and fixed number of ratio. It forms with fixed number of ratio. So that is known as constant proportions. Okay? And the today topic is completed. ఈ వీడియో కనుక మీకు నచ్చినట్లయితే ప్లీజ్ లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్ చేయండి. If you have any doubts, please comment on the comment box.